Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Hi, welcome to our lecture 2 for Green Technology HVAC subject. So today we're gonna go through to 3 subtopics. As I mentioned in lecture 1, there are several examples for green technology system, and I already mentioned in lecture 1, but today we're gonna go through the detail through the system, how it functions, the operation principle, and so on. And the second subtopic is the factors affecting air quality in a building, and the last one, how indoor air quality is affected by HVAC system. Okay, let us see the examples. This is the last slide that we stopped at. We have air-to-air heat exchangers, ground source heat pump, underfloor air distribution, variable refrigerant flow air conditioning system. Right, so we go to the first one. Air-to-air heat exchangers, or also known as waste heat recovery system. This system basically uses the heat recovered from the exhaust air to temper the fresh air coming into the building. So basically the fresh air from the outside will be preheated by the air from inside that is slightly warm than the fresh one here. So the fresh air comes in, the warm air cross the flow, and before it flows to the outside, so the fresh air already absorbed the heat from the warm stale air from the inside, and now we have the preheated fresh air to the inside. So by doing this, we lowered the overall load and we reduce the size of the air conditioning system because we reduce the load. So this is basically this system will results in better energy efficiency. Alright, the second system is ground source heat pump, and this system uses the geothermal energy by putting pipes and bury it in the ground to extract heat from the ground, and it is looped. The reason why it is looped is to increase the area to absorb the heat, so that it will have a better thermal efficiency. And the heat is then carried back into the house, and it is used, for example, for heat radiators, for warm air heating system, or as for us in Malaysia, we can use it for hot water. And ground source heat pump, what are the benefits of this system? Of course, it will lower the energy consumptions because we use the free heat energy from the underground. And as for the people in UK, United Kingdom, it could provide income through the government's incentive, renewable heat incentive, or known as RHI. But in Malaysia, this is to support the governments to find the renewable energy alternative, and for the equipment, Maybe you can check later. Maybe you can get the tax exemption for the green equipments. That's for Malaysia, right? And of course, when we use less electricity, then it could lower our home carbon emissions, because no fuel deliveries is needed. And for this system, it only requires a minimal maintenance. The third system, or underfloor air distribution, basically this system use the open space or underfloor plenum from between the lower story to the second level or upper story. In between the stories, there's a structural concrete slab. For example, this is level 1 and this is level 2. So in between we will have underfloor plenum, and you can use the space to put the air conditioning system, either for cooling or heating system, and we can deliver the conditioned air directly into the occupied zone of the building. There are several examples where this system is already installed. For example, the New York Times Building, Bank of America Tower, and San Francisco Federal Building. And as for Malaysia, in Suruhanjaya Tenaga, they also use the underfloor air distribution system in their diamond building in Putrajaya. Okay, and the benefits of this system, we will have the high ventilation effectiveness because it is directly from the floor near to the occupants, and with properly designed underfloor air distribution, the occupants' comfort will be higher compared to the conventional overhead cooling. What does it mean with properly designed underfloor air distribution? Properly designed means you have the right throw, you have the right air jet velocity. If you still remembered from the air distribution subject, you can see that this too is very important, so that the conditioned air could reach the occupants with the right proportion in the occupants zone, because not all space in the room is occupied. For example, between 0.8 to 2 meter is normally from the floor is normally occupied with people, right? The other benefit is to reconfigure space for tenants is less costly in building with underfloor air distribution, and its data floor boxes are easily moved so that you can accommodate the furniture modifications later. Alright, for disadvantage, we have to educate the designers, owners, tenants, and contractors, because they are not familiar with the approach. And there's also misperception that the buildings with this system is more expensive compared to the conventional one, and the maintenance cost is relatively high compared to conventional system due to accessibility and so on. Right, the last example is not the last, this is not all, but for the four system, this is the fourth one, the variable refrigerant flow air conditioning system. And VRF, actually this system has only one outdoor unit which serves many indoor units, and it is able to control the amount of refrigerant flowing to the multiple evap or indoor units with different loads, which means the rate of refrigerant that is flowing to every evap is different. Alright, this system is actually one of the most efficient system that we have right now to accommodate different zone or space load. So we can say that it provides an individualized comfort control in different zones. Alright, we still have several other green HVAC technologies that I'll explain in brief. For example, we have the on-command hot water recirculator. This system only provides hot water in timely manner, only when it is needed. Of course, this will save money, energy, and water compared to a system which provides the hot water all the time. Okay, you can visit this website, Taco. There's a video about the pump on the Taco website, and I just leave the name of the company for every innovation or technology here, so that you can Google later if you want to know more, how it looks, how it operates. Right, the second one is thermally driven air conditioning. This system is a hybrid system which use solar energy, and when it runs short, then the energy will be supplemented by the natural gas. Okay, and the third one is ice powered air conditioner, and this company comes with an innovation that can freeze up to 450 gallons of water in a tank overnight, so that it can be used for cooling for the next day. And the cooling can provide up to 6 hours. And if its ice has melted, then the system will revert back to building's conventional commercial air conditioning unit, which means the system is also a hybrid system, ice and also conventional commercial air conditioning unit. Alright, the fourth one is a quiet duct wrap. This is basically a recycled denim fabric which has low VOC, has no irritants. It is used as a duct wrap, as the duct outer insulation to reduce heat loss and gain. And it has no fiberglass, so better for the occupant's health, better for the skin, and it has class A fire rating. It's also good for safety, and it has aluminum barriers which protects from air currents, moisture and vapors, and unwanted radiant heat. It reflects unwanted radiant heat. Okay, maybe you can Google the quiet duct wrap from the Green Products Company to know more, if you want to know more. Alright, the fifth one is energy analysis software. And I believe by now, this is just an example, by now there's a lot of energy analysis software in the market, and it projects the most energy efficient and cost saving HVAC system for a space. Basically, it works like CHVAC software, and we can choose appropriate equipment in our design by using this software. It can also take non-HVAC techniques into consideration, into accounts, such as reflective roofing. The sixth one is a dual fuel heat pump. It is a combination of gas furnace and electric heat pump. For various for various temperatures. Okay, it use under 35 degrees, it use electricity, and for the lower temperatures, the pump utilizes gas heat to provide better efficiency. And hybrid system, normally it will have savings in terms of energy. In terms of initial costs, we will have to look at it more further. But at certain years, we have to look at the ROI, return on investment. If it is under 8 years, then actually the system is still worth to be installed. Alright, the last one is geothermal heat pump. Yeah, we have discussed about this in the earlier subtopics. Okay, let's see the factors that affects the indoor air quality in a building or industry. Let's look at the definition. What is actually indoor air quality? If you talk about indoor air quality, it is not only about thermal comfort, which means the right temperature, the right humidity, the most optimum one, but it also involves the quality of the air itself. Is there any presence of chemical, biological pollutants in the air or not? Is it more than the standard range, exceed the standard indoor air quality, or still in range, and so on? And of course, a poorly designed HVAC system will result in production of fungi, molds, and other sickness, which is caused by microbes, and for example, Legionnaires disease. Another example of bad indoor air quality is due to air tightness in a building, which causes by inadequate supply of fresh air, and as a result, it will develop negative pressure in the building. And you know, if the outside pressure is more higher than the negative, the pressure in the building, other pollutants from the outside will be drawn into the buildings. For example, from ground level pollutants, CO, radon, etc. and release of odor, bioaerosols, and polluted air from the vents, cracks, any openings in the building, dust, pollen, everything will be drawn inside the building, and this will cause sick building syndrome. Another example of bad air quality is due to wall paint, indoor source of pollution, which has, for example, high VOC, high volatile organic compound that will affect the occupant's health. And another example is if the air intake is near smoking area or garbage bin. This we can name it as outdoor sources of pollution. This will also lead to bad indoor air quality. Right, this is several examples of paint, indoor wall paint that contains volatile organic compound. And before you buy any paint, you can actually compare whether it has high VOC or low VOC, low odor, because we know the odor could also affect the occupant's comfort. And paint with high odor will cause to discomfort of the occupants. Right? So make sure you do the comparison. Yeah, for indoor air quality contaminant, of course, it will lead to health problems. And there are two categories that we can classify the effect into. One is the immediate effect, and the second one is a long-term effect. As for immediate effect, the occupants could get eye irritation, nose irritation, throat irritation, headache, dizziness, fatigue, asthma, and hypersensitivity pneumonitis. And as for long-term effects, for example, the occupants inhale too much VOC for a long time. This will lead to respiratory disease, heart disease, and even cancer. The worst one. So we're going to see how indoor air quality is affected by HVAC system. Here first we can see the design of the air conditioner itself and also the ventilation system. If it is poor design, then it will lead to bad indoor air quality also. Second one is a poorly maintained HVAC system. Every system, any system, if you get the best filter in the world, the most expensive one, and even the electronic automatic electronic filter with good filtration, it cannot be forever good if you do not maintain the filter. So you have to check timely according to the schedule and do the maintenance to clean it so that the incoming air that is filtered by the air filter is really clean, and the filter does not cause the air to carry the dust or the pollutants on the filter itself into the space. Right, the third one is the materials. Materials of the structure of your structure. If there's carpet, the wall, the materials of the wall, the materials of the paint, the materials of the roof, and so on. So make sure it is not a high emitting toxic, chemically non-inert, to avoid this kind of materials. Okay, this has nothing to do with the air conditioning system. And then if tobacco smoke, someone having their cigarettes in the toilet in a building, for example, or in any room in a building, in air conditioned building, then the tobacco smoke will be carried into the system and it is distributed to all occupants of the building. So everyone share the bad indoor air quality together. So sama-sama cepat mati. Okay, so the humidity. If your air conditioning system is not properly designed and for example your system is too big for the space, then it will turn off in a short time, which causes the cooling coil to condensate only to a certain amount of humidity. It cannot do the dehumidifying process as it's supposed to. Then you will have humidity problem, and later on condensation, and it will lead to fungi or mold problem, which causes Legionnaires disease or any other problem with IAQ. I mean, for example, the what we call this, respiratory problem. Yes, that's a word. All right, so the next one, ventilation and distribution. If you use hard to seal building cavities such as drop ceiling plenums, then you will have bad ventilation, and this will cause you bad IAQ. And the last one you already discussed, VOC, volatile organic compound emission. Okay, so this is the examples of filter look that is not maintained. This one is dusty, this is dirty, this one is clean, this one is dirty. And even our home air conditioner system should be maintained as well weekly, so you can see whether there's dust. So this one you can wash it, actually just wash and let it dry for 30 minutes and just put it back, and yeah, you can use it again. And this one is a chemical maintenance, using chemical to clean all the dust, all the rust, for example, in the air conditioning system, in your split unit system. So just imagine this one is not clean, then the blown air will carry the dust together, the dust particle together with you, and not to mention the bacteria or any unwanted particle which is embedded in this dirty filter, will be carried into the space also. Okay, this is actually the mold problems that are caused by humidity, high humidity, or unbalanced cooling between several zones. For example, you have in a level, you have on the same level, you have a zone where there's cooling, use a cool air, and there is also zone that is not air conditioned. Cool air, I mean, that's not involved with the cooling. For example, in an office building, for example, in a pantry, it does not have any outlet for the cool air to come in, and there's zones where the staff's room, which is cool, and yeah, then this hot air and cool air will the what do you mean do the encounter of the hot air and also the cool air will cause condensation, and also, and of course it will lead to mold production. So the thing is, you really have to think when you design a system, any system for any building. So you will have to see the arrangement of the rooms, how to balance the cool and hot air so that the condensation does not occur, and where does it need to be sealed so that not everyone can open the window just like that and cause the hot air to come in, and so on. So that's how the HVAC system or air conditioning system can affect the indoor air quality. Alright, so there is suggestions for improving air conditioning system so that we will have a good indoor air quality. The first one is to know the source of the problem. For example, just now, mold. So we have to know how to control the source. There are several steps that we can use to control the source. I just mentioned it here. Hierarchy of control. There's elimination, isolation, segregation, engineering control, and administrative control. These are the control hierarchy. So how to eliminate the mold, how to isolate the mold, and for example, if we know the source is the zones, two different zones are on one floor. For example, in hospital, if you have class 1 ward and second class ward on the same floor, and the second class ward uses fan, for example, maybe you can relocate the second ward to the higher level, and just make sure you do not sandwich two levels, cool and hot in between, hot in the middle, for example. That will also cause condensation. So you really have to design a system according to the needs and according to the rooms arrangement or usage in the building. The second one is you can improve the ventilation. There's so many ways in improving ventilation. You can use the fan, the suck to suck out the bad odor. For example, in the kitchen, you can suck the air out from the kitchen, which contains your cooking's residue, your the smell, the smell from your cooking and so on. Can suck it out, and if it is needed, you can provide the incoming air by placing any fan to suck the fresh air in. Just make sure that there is no it is balanced and there is no problem with condensation, that any source that can cause condensation. And the third one is the utilization of air cleaner or air purifier. Of course, your air conditioner can also filter all the unwanted particles and so on, but up to certain limit. Maybe to the specific size of particles, you will need support from air purifier. This is just examples of several suggestions. Maybe you can add on more.